Okay, so I'm going to go ahead and get started here. I'm speaking about full hydrogen retrofit solutions for existing gas turbine heat and power plants. I want to explain a little bit about our background first. We're part of Hanwha, which is a global corporation, a big emphasis on the energy transition. And you can see just in terms of sales volume, 65 billion, Hanwha is truly a world player. And so their idea for sustainability, our idea for sustainability is really one that's all-encompassing. And I want to explain a little bit what that means here. So we touch every element of a green energy solution, from solar panels to wind, to hydrogen production, to actually even the movement of ammonia and hydrogen around the world through a shipping company, which we own. And then ultimately, when it comes to our company, Thomassen Energy, we're responsible for providing the retrofits, the solutions that can be installed in existing power plants to make use of hydrogen, which is then also provided by this circular economy. You see a couple of pictures here. QCell investing $2.5 billion in a gigafactory in the US. Hanwha Ocean, carbon-free shipping using ammonia propulsion systems. This is coming within the next 3 years. So it's a global effort. I'm going to focus a little bit more on the business that I'm responsible for in the Netherlands here. That's Thomassen Energy. So at Thomassen Energy, we have a sister company here, also PSM, Power Systems Manufacturing, based in the USA. Between the two of us, we cover the 50 and 60 hertz markets of the world. And we provide field services for working on the gas turbines in the power plants. We can do all the repairs that are needed for the equipment that goes into the machines. And we focus on upgraded components. So we develop upgrades for existing gas turbines. And one of those upgrades that we've been working very hard on in the last 5 years are the hydrogen upgrades. And then we also do service support, digital monitoring. So wherever we are in the world, we can monitor the operation of a power plant. And that means anything really from a machine of around 20 megawatts to about 300 megawatts. So a lot of the energy that's supplied today is coming from these kind of gas turbine power plants, and we can cover most of that portfolio. So if you look at the Dutch example, how renewable electricity is coming to the market and how it's the main driver maybe for Dutch society can be in the use of gas turbines, combined cycle gas turbines, backing up the grid. So there will be massive amounts of hydrogen that's imported into the Netherlands in the form of ammonia, likely. That hydrogen can be stored in the salt caverns in the north of the Netherlands, and then it can be distributed through a pipeline network that's running throughout the Netherlands to industries, to power plants, and those facilities can then tap into that as a resource to produce clean energy, especially in times when there's a need for balancing. Maybe when the sun's not shining and the wind's not blowing, there's a standby clean source of energy generation with an existing power plant. So why are hydrogen combustion systems needed? Why do we need a retrofit in a gas turbine power plant? Well, they're already installed. They're already grid connected. So from that perspective, they're almost ready to go. They're highly dispatchable. So today, gas turbines are really taking the cyclic load on the grid. And they're very cost effective. They can rapidly ramp up and down in power, so providing the grid stability that's needed. There's spinning reserve if you want it, so you can have literally within minutes, on-demand, massive quantities of electricity, megawatts of electricity, and also stabilizing the grid for the frequency fluctuations that you can see when we have renewables coming onto the grid. They're fuel flexible, so you can pretty much put anything that burns into a gas turbine. It just needs a source of heat. And of course, one of those things is fuels like hydrogen and ammonia. And so we developed partnerships across clean energy industries to evolve and install this into gas turbines. So just so you know what a gas turbine is, essentially you compress air you burn it in a combustor, and then you blow it out through a turbine. So this is a device that we're talking about. We really focused on the combustor piece of it here. So this is where we do the retrofit. So it's a surgical implementation into an existing machine. And there you can then start to consume refinery off gas or high hydrogen fuels, and you can do it on gigawatt scales. So it really becomes like a super battery if you have a salt cavern or you have an ample storage facility, or you already have a waste gas. You can generate gigawatts of energy using this. And if you put it into a combined heat and power application, the efficiency is 80 to 90%. Okay, so you're really able to capture most of that energy that's in the fuel. Here's an example of a real implementation. This is Dow, very close by here in Thomassen. They have 390 machines, so that's about 120 megawatt machines. And we did three things to these machines to adapt them to be able to run on hydrogen. We update the fuel delivery system so you can bring in hydrogen as well as natural gas. We update the control system. This is what manages the gas turbine in a safe way so that it can interchange the different amounts of hydrogen fuel that might be available. And then there's a combustion system retrofit. So the combustion system is developed in a way that it can accommodate these highly reactive fuels. This facility has been in operation since 2018, all three machines. Sub 9 ppm NOx operation from 0 to 35% hydrogen. That takes about 60,000 tons a year of CO2 out of each gas turbine, running that amount of hydrogen. The hydrogen is coming from the Dow facility adjacent where they have waste gas. So for them, it's win-win, right? They are reducing their carbon footprint and they're saving money, not having to burn natural gas. So burning waste gas consumption with high hydrogen is really a key element of our solution. Now, we've developed something called the flame sheet platform. This is a common product that can be fit into multiple different OEM-style machines. So that's the General Electric machines, the Siemens machines, the Mitsubishi machines, and as I said, anywhere from 20 megawatts to 300 megawatts. It gives you extended fuel flexibility, actually the ability to run on existing natural gas, but switching ultimately towards full hydrogen and full waste gas applications. It gives you an extended range of operation and compliance, which is needed on the grid today. And then also sub 9 ppm, single-digit NOx and CO emissions with an extended lifetime, at least 32,000 hours of operation. We already have this deployed. There are 30 machines around the world that are operating with this technology. 22 of them are on GE machines, 6 are on Siemens machines. A lot of it is on F-class machines that you see there in the United States. But now we've also been doing some high hydrogen installations. We have now 4 commercial operating machines with hydrogen using this platform. So this is not something that we're thinking about doing. This is something that's already implemented. Last year, we also took the next step, and that's going towards 100% hydrogen operation. What you see there is a dial going from 0 to 100% hydrogen. The key here is that we give the operator the ultimate flexibility to decide what fuel is available for them, and they can select whether they want to run full natural gas, portions of hydrogen, or even full hydrogen. Hydrogen is a very tricky fuel to burn. It has a much higher flame speed than natural gas. It doesn't always behave the same way. So it takes a lot of design upgrades and manipulations to be able to run flexibly from 0 to 100%. And this must be done continuously. It must not affect the operation of the power plant. So even if you have a sudden upset in the supply of the fuel, your gas turbine, your power generation must remain stable. So these kinds of tests are very important. This is a facility that we use in Germany at DLR, the German Aerospace Research Center, and we take the real engine hardware and we test it at full pressure, full temperature conditions when we do tests like this. And you can see as we go from 0 to 100%, you get this blue pre-mixed flame with the methane, and it goes completely invisible now at 100%. Right? So hydrogen flame is not visible. So this kind of testing is really key to the development of the technology that we're talking about. And then when you look at the implementation of this, of course, where does the hydrogen come from? That's a big question. It's going to be imported maybe from the grid. It can also be reformed from natural gas. Maybe it will also be generated through electrolyzers. whatever the mechanism is, there's a pathway to put it into an existing power plant. So that element of it is already existing, it's already in operation. We just need to bring the additional pieces of equipment adjacent to it, and really with a minimal investment, you have a facility that can run carbon-free. Off-gas is something that's very valuable. People often will ask, well, where's the hydrogen coming from? It's too expensive. But if you ever look around you, if you see a flare from a refinery or from a field, there's likely high quantities of hydrogen in that flare. That's being wasted. If we capture that flare gas, you're not only burning hydrogen, you're also utilizing hydrocarbons that otherwise would just be vented to the atmosphere. This technology we have is able to consume that as well. So a big push for us is to address the waste gas opportunities. Maybe in countries as well where there's not widely green hydrogen available, we can still make a big impression using this waste gas consumption approach. These are the commercial retrofits that are in place today. So you see they're all quite recent. The one I already mentioned there in the bottom was the one in Dow. But you can see that we've had a number of implementations over the last years over a range of machines, everywhere from 20 megawatts up to the 200 megawatt scale. So these things are really happening. We have one in Rotterdam that we just finishing up right now. It's just at Uniper, where they'll have the capability to also run up to 30% hydrogen. I'm just going to show you this quick video of a plant that we implemented in 2023. It can run up to 60% hydrogen. So it really shows you the full scope of what's required to do a hydrogen upgrade. It's really not just the gas turbine. Here we used hydrogen fuel supply trailers to augment what was already available in the refinery, because we wanted to push to very high levels of hydrogen for the demonstration. So this was a brownfield. There was nothing on this piece of land in 2021. Okay, so in a year we moved the gas turbine onto the site. We brought all these elements together and we did this demonstration. So it's important to understand that to put the system together, there's a lot of ancillary systems which we also have to support for the full implementation of the hydrogen solution. So just to wrap it up, what's the advantage of this kind of retrofit approach using this flame sheet technology? Well, you already have the power plant in place. No need to build a new one. Make use of what you have. It's already readily dispatchable, sits on the grid. It's very cost effective as an energy conversion device. Highly flexible to balance the grid, to firming whatever is required for the grid. It's an opportunity for clean energy storage as well when the storage is available. It's fuel flexible. Ability hydrogen, waste gas, but also natural gas. It's a spinning reserve that's available on an instant of notice for the rest of the grid, and it's cost effective. It's a surgical retrofit. So in the end, it's a high hydrogen combustor retrofit for a carbon-free power generation and energy storage, and it's using a common modular technology. We're always looking for new people to join our team, so I'll just mention that people are a big part of who we are. So if there is anybody out there that's interested in pursuing something along with us, we're always looking for talent. Thank you very much.